Okay, good morning, good afternoon, class. So today we're going to talk about speed and velocity. So up to now we've spoken about distance and displacement. Now we're going to talk about speed and velocity. Okay, and really they're both just measures of how fast we're going. So speed is a measure of how fast we're going. I think we're all familiar with speed. We might have a speed of 50 miles an hour, we might have a speed of 100 miles an hour, we might have a speed of 10 feet per second. Okay? In this class, we're primarily going to be using speed in meters per second, but other units will be used as well, particularly in positive physics. Okay? So speed is basically how far did you go in a certain amount of time. And we usually normalize that back to one unit of time. So it'll be how far did you go in 1 second, or how far did you go in 1 hour, and that would be your speed. I traveled 10 feet per second on average. I traveled 50 miles per hour. Those are speeds, 10 feet per second, 50 miles an hour, 5 meters per second. Velocity is pretty much the same thing, how fast we're going, but we also include direction. Okay, so velocity is a vector. Velocity has direction associated with it, speed does not. Okay, so an example of a speed might be 60 miles per hour. An example of a velocity might be 60 miles per hour west. Or we often use, if we're talking about one-dimensional motion, we could talk about one direction being negative and one direction being positive. So west would be negative, east could be positive. In this case, we describe that as negative 60 miles per hour. Okay? So velocities can be positive or negative as an indication of direction. All right, let's talk about average speed and velocity. Okay, average, very, very important to hone in on this word average. That's why I highlighted it in red. Right now we're talking about the average speed and the average velocity. Okay, so average speed is basically the distance that an object moves divided by the time that it took to move that far. Okay, distance divided by time. So speed is distance divided by time. Average speed, average. Okay, and what that means is in many situations, the speed isn't perfectly constant, right? If we take a trip in our car, we might drive along kind of fast at times. We might hit traffic lights at different times. Um, we might even move in different directions. We might kind of go north and then a little south and so forth. But ultimately, if we look down at our speedometer, we will have covered a certain amount of distance, and it will have taken us a certain amount of time to do that trip. And our average speed would be that distance divided by time. Okay, so if we traveled, just to use units of meters, if we traveled 1,000 meters in, and we were driving along for 100 seconds, our average speed would be 10 meters per second. Okay, so as simple as that. Just the total distance that we traveled divided by the total time it took to travel it, that'll give us our average speed. And again, in this situation, the way I described it, right, sometimes we stopped, we might have stopped for a few seconds at a traffic light or at a stop sign. We were going maybe somewhat fast sometimes, somewhat slower sometimes. Doesn't really matter. We're just our average speed. Remember, average is a measure of kind of the center of some numbers, right? Average is kind of a measure of midpoint. So the average doesn't tell us exactly how fast we were going at every moment in time, but it gives us a sense of the midpoint of our speed, right? So if we traveled 1,000 meters in 100 seconds, our average speed would be 10 meters per second. Okay. There is a formula in the reference table. Well, actually, let's talk about velocity first, then we'll talk about the formula. Okay, so average velocity is pretty similar to speed, except we're not talking about distance, we're talking about displacement over time. So average velocity is the displacement of an object divided by the time it takes to make that movement. Okay, so remember, displacement is a vector, so displacement has a direction associated with it. And if we moved, let's say we moved 800 meters to the right, and then we moved 200 meters to the left, and we did the whole thing in 100 seconds. Okay, so this would also be 1,000 meters of total distance traveled in 100 seconds, except from a displacement point of view. If you remember, displacement is how far away did we end up from where we started to where we ended. So in this case, our displacement would be 600 meters to the right. Let's call that positive 600. And so in this case, our velocity would be 600 meters divided by 100 seconds. And so we would have positive as an indication of direction, 6 meters per second. So our average velocity would be 6 meters per second in the positive direction. Okay, so that's velocity. Velocity is displacement, the displacement that we ended up with divided by time, whereas speed is the distance, total distance that we traveled divided by time. Okay, and just I'd like to refer things back to the reference table. If you look at page 6 of the reference table, and page 6 is basically what we're going to be covering for first semester. The very first formula on page 6 of your reference table is this: V with a little bar over the top equals D over T. So the bar over the top means average, just like the bar over the top here means average, and the bar over the top means average. So we'd say our average velocity is equal to displacement over time. And on the reference table, they don't really come up, they don't give a separate formula for speed. They don't say average speed equals distance over time. They just say this V bar, or that rather they say D, for example. They say D, you can think of D as representing displacement or representing distance. Okay, and if I scroll down a little further, they would say you could think of this V as representing velocity or speed. But anyway, just wanted to highlight, this is what you see on the reference table. Average velocity equals displacement over time, and you could also think of it as average speed equals distance over time. All right, but anyway, again, average speed, distance over time, average velocity, displacement over time. All right, let's do an example. Hopefully it'll make that clear. All right, over here we've got average speed and velocity example. A bicycle takes 15 seconds to travel the loop shown in the diagram below. Calculate the average speed and the average velocity of the bicycle. So here we have start, end is right here. So this is where we're starting. And then we move 10 meters over, and we move 5 meters down, 10 meters in the opposite direction, and 5 meters up. Okay. All right, and it says it takes 15 seconds to do that. It takes 15 seconds to travel. So they're giving us the time, 15 seconds, and they're asking us to find the speed, and they're also asking us to find the velocity. All right, well, let's start by finding the speed. And by speed, we mean average speed, right? They're asking us to calculate the average speed. All right, well, average speed, we said, is distance over time. The distance we traveled divided by time. All right, so what is our distance? Well, we went 10 plus 5, 15 plus 10, 25 plus 5, 30. So our distance is 30 meters, and our time that it took to do that is 15 seconds. So distance over time, our average speed is 2 meters per second. Okay? Now this is speed. There's no direction associated with it, as it would be difficult to describe which direction our speed was in, right? Our direction really was in a bunch of different directions, right? So for speed, if we're going to say what is the direction of this 30-meter movement, well, you really can't give it a specific direction, so we don't. So we're going to say, but we did travel a distance of 30 meters in 15 seconds, and so we traveled at an average speed of 2 meters per second. Velocity, on the other hand, is displacement over time, the displacement that we ended up with over time. Well, we started here and we ended here, so our displacement is 0. It took us 15 seconds, and so our velocity would be 0 meters per second. And since there really is no displacement, we don't have to write a direction in this particular situation. Okay, but that's the difference between speed and velocity. Speed is distance over time, velocity is displacement over time. Let's do a couple quick examples. Okay, speed versus velocity. All right, let's read this first problem. A 4-kilometer race. So this guy is going to be running for 4 kilometers. That's 4,000 meters. The runner completes the first kilometer in 5.1 minutes. So the first kilometer in 5.9 minutes. The second kilometer in 6.2 minutes. So the next kilometer in 6.2 minutes. The third kilometer in 6.3 minutes. The next kilometer in 6.3 minutes. And the final or fourth kilometer in 6 minutes. So the last kilometer took 6 minutes. And it asks us to find the average speed. So average speed, remember, speed, average speed, or we could simply write it as V, okay, equals distance over time, right? What is our distance? Well, our distance is actually these guys, right? We traveled 4 kilometers. It was a 4-kilometer race. Our distance is 4 kilometers, 4,000 meters. And our time, well, these are our times here. So we have to add these up. So 6 plus 6 plus 6 plus 5. Okay, 6, 12, 18. 18 plus 5 is 23. 24.1, 24.4. Okay, so we add those up and we get 24.4 minutes. Okay. We look at our answers, and our answers actually are in kilometers per minute. Most problems are going to have meters per second as the answer, the units of the answer. But in this case, it is kilometers per minute, so we can leave the units as is and simply do the division. 4 divided by 24, plug that into your calculator. This is approximately 1/6. So we know 1/6. This is about 1/3. This is about 1/6. When you plug it into your calculator, you'll get 0.16 kilometers per minute. We're done. Okay, so that is speed. Okay, so they didn't give us any indications of was he running in a straight line the whole time? Was he running sometimes in the north direction, sometimes in the east, sometimes in the south? It really didn't say any of that stuff. But we don't care with speed because speed is distance divided by time. And so they gave us the distances. We don't really care what direction those distances were in. We just add up the distances, add up the time. Speed is distance over time. All right, let's look at another problem. So this problem says a car traveled 90 meters due north. They're giving us a direction in 15 seconds. Then turned around and travels 40 meters due south. Again, another direction in 5 seconds. Gives us some more time. What is the magnitude of the average velocity? So magnitude means the how much portion. We don't care about the direction. What is the magnitude of the average velocity? Okay, it's asking us for the average velocity. What is the magnitude of the average velocity over this 20-second time period? Okay, so we know average velocity is displacement over time. Okay, now the time is, we have 15 seconds and then another 5 seconds, 20-second interval. So time is 20 seconds. All right, but what is our displacement, sorry. So we went 90 meters due north. Okay, so that's 90 meters. 90 meters due north. Okay, and then we turned around and traveled 40 meters due south. So we went 40 meters due south. Okay, so if we started here and we went 90 meters up and 40 meters back down, what is our displacement? Well, our displacement would be 50 meters up or 50 meters north. Okay, so we would say our displacement is 50 meters north. Okay, we can leave the north off, but if you wanted to, you could put like a little N over here for north. Okay, we divide these. 50 divided by 20, well, you can divide both numbers by 10, you get 5 over 2. 5 over 2 is 2.5. So we get 2.5 meters per second average velocity in the northward direction. Make sure the decimal is clear. All right, so 2.5 meters per second in the northward direction. It's asking for the magnitude of this average velocity, so we don't care about the north portion, we just care about the magnitude, the how much portion, 2.5 meters per second. And so boom, we have our answer. Okay. So again, so speed is what distance did we cover divided by time. Velocity is what displacement did we have divided by time. All right. All right, so concept isn't so crazy. All right, so but a couple of little details that you guys should be aware of, and then you'll be in pretty good shape to do almost everything in this unit or in this section. Okay, the first thing I want you to know is that you're going to encounter three kinds of velocity. Okay, one is just sort of they don't really say much about the velocity, in which case you have to assume that the velocity is not steady. So, and just to give an example of that, let's say you know you're running from home to the store. Okay, and the store is 2 miles away. So you start out, you're kind of running at a certain speed. Let's say you're running at 2 meters per second, just to put a number on it. So you're covering about 6 feet every second as you're running along. And then you get tired, and so you kind of slow down, and then this axis is time over here. Okay, so you sort of slow down, and then you kind of cruise along, and then at the end you sort of say, let me speed up, and just for the fun of it. And so you speed up, and then you go a little bit faster, and then you hit the store, so you stop, so you end your journey here. Okay, you could actually go boop, and my velocity goes down to 0. Okay, so this is one situation, and again, how do we compute the average velocity? We would take our displacement and divide it by time. It's very simple. Now, in order to calculate the average velocity in this situation, you would have to know, they would have to tell us, well, how far away was the store from home? They would have to tell us the displacement that you had between home and the store, and they would have to tell us the amount of time that it took to run there. And once I knew those two things, we could calculate our average velocity. Okay, not a problem. The second situation, and average, again, average is kind of a measure of midpoint, right? So your average velocity is always going to be below the highest velocity and above the lowest velocity. So our average velocity would be somewhere between your lowest velocity and your highest velocity. All right, now a second situation that occurs a lot is to basically say, hey, you're moving at a constant speed or a constant velocity. Okay, so just be sensitive to this word. And this, what's important to know about this is when you're moving at a constant speed or constant velocity the whole time, okay, so you never go any slower, never go any faster. What's important to know here is that my average velocity, which I can use in my equation, distance equals average velocity times time, right? What's important to know here is that my average velocity is equal to my constant velocity. My average velocity is equal. So if you get a problem and they tell you, I'm traveling at a constant velocity of 3 meters per second, they didn't explicitly come out and say, during this trip you had an average velocity of 3 meters per second. But if they tell you you traveled at a constant velocity the whole time, they've just told you the average velocity. Okay, so if I'm traveling at, let's say, let me say 20 meters per second. It says I'm traveling at a constant of 20 meters per second. That means at the beginning I'm traveling 20 meters per second. When you first started observing me, I was already traveling at 20 meters per second. I didn't speed up to 20 meters per second. I've been traveling at 20 meters per second, and you began observing me at some moment in time. So every moment in time, I've been traveling at 20 meters per second. Well, if I'm always traveling at 20 meters per second and that doesn't change at all, my average velocity is also 20 meters per second. Okay, so just make that connection. If I'm traveling at a constant speed or constant velocity, my average speed or average velocity will be the same as that constant speed or constant velocity. Let's do an example. We're going to do this one down here. A car is moving with a constant speed of 20 meters per second. Okay, so we're talking speed. What is the total distance the car traveled in 2 minutes? And let's look at our units. Our units are meters down here. Okay, so it says my constant speed of 20 meters per second. And it's asking for what is the total distance. Well, we know distance equals average velocity. Displacement equals average velocity times time, and distance equals average speed times time. Okay, so we can think of d as displacement or distance and v as velocity or speed. So displacement goes with velocity, distance goes with speed. All right, so we're going to say distance, which is what we're trying to find, is our average speed. Okay, now it doesn't say what is the car was traveling at an average speed of 20 meters per second. It just said its car is traveling at a constant speed of 20 meters per second. But you know, if it's traveling at a constant speed, that is also the average speed. So we can plug that in. We can say our distance is 20 meters per second, and distance equals average speed times time, right? So we can plug this in, even though they didn't say average speed, they said constant speed, but we know that if we're traveling at a constant speed, the average speed is the same thing, times time. Now they put 2 minutes. Problem with 2 minutes is we have seconds in our speed, right? So we have to convert 2 minutes to seconds. Well, we know 1 minute has 60 seconds, so 2 minutes have 120 seconds. So we plug that in. And our distance, seconds cancel with seconds. Our distance is 2 times 1 is 2, 2 times 2 is 4, 2 times 0 is 0, times 10, 20, or just plug it into a calculator. 2 times 120 is 2,400. And we have our answer, 2,400, which is down here. Okay, so besides the unit conversion from minutes to seconds, the key was understanding that if you're traveling at a constant speed, my average velocity is the same as my constant speed. My average speed is the same as my constant speed. If I'm traveling at a constant velocity, my average velocity is the same as my constant velocity. Okay, so when you see constant velocity or constant speed, you should be thinking to yourself, they just told me the average velocity or average speed. Okay? Well, actually, we'll come back to that. Okay, and then the last situation. So one situation that you're going to encounter is where the speed kind of varies all over the place, or the velocity varies all over the place, and they don't really tell you much. That's kind of this situation. If the second situation is the speed is rock solid, steady the whole time, that's constant velocity. What you should be thinking about when you see a constant velocity situation is that the constant velocity is the average velocity, okay? And the third situation that you're going to encounter is a steadily changing velocity. So let's say we start off at some velocity, 15 meters per second, okay? And we speed up to some other velocity, let's say 21 meters per second. So our speed changes. Our speed is going up. We're getting faster. But it's not going faster in some random fashion, or it's not going faster in some herky-jerky fashion. Like sometimes it gets faster quickly, sometimes it gets faster slowly. No, it's the situation you're going to be given is where it gets faster steadily. It gets faster uniformly. It gets faster linearly. Okay? So here we have a car, let's say, that's getting faster. Again, this is time, and this is speed or velocity. And so that's the situation you're going to get. A car is getting faster, or a car is getting slower. That would be a decreasing slope. Okay, but in any event, if your object is speeding up steadily or slowing down steadily, you're going to see this kind of situation. And this, we would call this the starting velocity, or the initial velocity, or the original velocity, and this is our final velocity. Okay, so when you're given this situation, you're going to be given a starting velocity and an ending velocity. What you need to know about this to use our good old formula, distance equals speed, average speed times time, or distance equals average velocity times time. How can we figure out the average velocity in a situation like this? Well, what you need to know is that the average velocity is the velocity right when it's a situation where it's steadily increasing or decreasing. The average velocity is the velocity, it's basically the midpoint between these two velocities. You'd say, well, what's in the middle of these two numbers? What's in the middle of 15 and 21? Well, 15 and 21 are 6 away from each other. Right? 21 minus 15 is 6, or 15 plus 6 would get me to 21. So what's half of 6? 3. So if I went 3 up from 15, I'd get to 18. And if I went 3 up again, I'd get to 21. Right? 15 plus 3 is 18. 18 plus 3 is 21. So the midpoint would be 18. Okay? And this is the average velocity. Okay? Half the time that this car was speeding up, half the time it was below 18 meters per second, and half the time it was above 18 meters per second. And since it's uniform, this is our average velocity. Okay, so how do we figure out the average velocity? In a steadily changing velocity, just take the midpoint between your starting velocity and your ending velocity. Or you can also just average these two numbers out. And how do we average two numbers out? We add them up and divide by 2. So we can say V average in this situation is our initial velocity, VI, plus our final velocity, VF, divided by 2. Okay. What is our initial velocity? 15 meters per second. Plus, what's our final velocity? 21 meters per second, divided by 2. 15 plus 21, that's 36. Divided by 2 is 18. So we get, that's just kind of another more purely mathematical way to come up with your average, okay? Initial plus final divided by 2. 18 meters per second. Okay, now this only applies in a steady situation, so steadily increasing or decreasing. It would also apply in this situation. We could consider this as our initial velocity, and this as our final velocity. Right? We'd say, well, what's right in the middle of 20 meters per second at the beginning and 20 meters at the end, 20 meters per second at the end? Well, our midpoint velocity would be 20 meters per second. Or if you added them up and divided by 2, 20 plus 20 divided by 2, that would be 40 divided by 2 is 20, which would get us to 20. Okay, so you can apply this formula in this situation as well. You cannot apply this formula in this situation because it is not either a constant velocity or a steadily changing velocity situation. Okay, but if you have a steadily changing velocity, our average velocity is the midpoint velocity. Okay, so let's do a problem here. And I've sort of already begun the problem. A car is traveling on a straight road, so this is one-dimensional motion, at 15 meters per second. It accelerates. Accelerates means speeds up or slows down. But it doesn't just accelerate, it accelerates uniformly. It uniformly accelerates to 21 meters per second. It does this in 12 seconds. What is the total distance traveled by the car in this time period? Well, as we said, we started at 15 meters per second. We uniformly increased to 21 meters per second. So what's our average velocity? 18 meters per second. Or our average speed would be 18 meters per second. All right, so let's plug it in. So the distance that we traveled, or our displacement, would be 18 meters per second. That's our average velocity, which we figured out by taking the midpoint of our starting and ending velocity, times time, which is 12 seconds, okay? And then we multiply these. So 180 times 18 times 10 would be 180. 18 times 2 would be 36. 180 plus 36 would be 216. Okay, so we got our displacement would be 216 meters in the positive direction, or our distance would be 216 meters because we're traveling in one direction on a straight road. All right, so that would be our answer, 216 meters. So the key is understanding that you're going to be given three types of problems. Kind of velocity that changes a whole bunch, in which case all you really can do is if you know the total distance that you traveled and the total time that you spent doing that motion, you can figure out the average velocity. If you're given a constant velocity or constant speed problem, as soon as they say constant velocity or constant speed, you should be saying, aha, they just told me the average speed or the average velocity. And the third situation is a steadily changing speed, okay, or steadily changing velocity. And in that situation, it is when you're uniformly increasing your velocity or speed or uniformly decreasing your velocity or speed, the midpoint is the average velocity. Okay? And I think that's good for today. That should give you enough information to solve about 95% of the problems that you'll be encountering this week. We'll discuss a little bit more tomorrow and the next day, but that should help you out. Okay, that's it. Thanks. Bye.